Welcome back. Today we're looking at another equation. Now remember, if you look at the last one, we only had x, v, and t. This one does not have an x in it, so we're not looking for a distance or displacement. We have two v's, a v, and this is called v naught. That's not v times o, it's v sub o. We have an a, a new letter, and our t. So the v by itself is final velocity, v sub naught is your initial velocity, our new letter a is acceleration, and t is time. If you look over here, that anytime you see velocity, it's in meters per second, time is in seconds, whereas acceleration is meters per second squared, or that's a short way of saying meters per second per second. So our today's equation is v equals v naught. You notice this naught is not in the same level as our v, because if I did, it'd be v times 0, and that's not what we want. We have an a and a t. So let's go back. It says at rest. Ooh, what does rest mean? It means that there's no velocity. So there's the v there. At the rate, okay, there's meters per second squared, and knowing our units, there's our a, and there's a time, and it says what is the new velocity. You notice we have two v's, and it's up to you to figure out which v goes where. Remember that v naught is the initial, in other words, the starting point. So I'm looking for, I have a 0 here. At rest means there's no velocity. We're looking for our v plus a, which is 4.5 times our t, which is 8.5. v will be in meters per second, as we have already said. You notice that's a nice slash. Don't make it up vertical to make it look like a 1. We'll skip this one. Let's go to the next one. Car increases its velocity from, okay, there's one v, to another v, okay, in a time of, okay, there's seconds. Says what's the acceleration? So our equation of the day, v equals v naught plus a t. So you notice it's 20 equals 2.5 plus, we're looking for the a, and the t is 0.34. A, there's our unknown, and it will be in meters per second squared. I'm skipping that one since that's an acceleration problem. You can work these on your own, since you already have an example. Okay, a car accelerates at a rate of, there's an a, meters per second squared for 10 seconds. Our time to a velocity of, okay, now, is this your final or the initial velocity? Here's your clue. It says, what was the car's initial velocity? So, when we write down our equation, v naught plus a t, says what's the initial? This is what we're looking for here. Okay, so we're just plugging, since we've got everything labeled. A is 3.5, t is 10, so v naught, and from up here, is in meters per second. I'm assuming with your math skills you should be able to solve for v naught. This is not my part. I'm just showing you how to set up, substitute, and the units for the answer. Now we can also ask how much time. And then there's our v, and there's your a. So v equals v naught plus a t. Substituting, we notice it's from 2. The 2 is your final. This is where it starts, plus 3t, and t is in seconds. I'm going to show you this one. Now, acceleration can be negative. In this course, we're going to say if you're speeding up, in other words, your velocity is increasing, acceleration will be a positive value. If you're slowing down, in other words, you're going from a faster velocity to a slower velocity, you're decelerating. In other words, you're getting negative acceleration. That's a good rule of thumb, even though some textbooks will try to lead you astray and go the opposite. This way it's easier for you to remember. So we just do this. So there's our A, looking at our units. There's our V, and there's another V. So it says a final, and then the initial velocity, this is this, plus A is -5. Don't forget your negative. And then 6.8. Now V0 will be in meters per second. You're probably looking by inspection, your V will probably be a negative on this one. That is correct. Remember, velocity has a direction, and therefore it can be negative. Remember, I'm going to let you work what's left. If you have any questions, feel free to contact me.